Welcome to doassignment-ca. Here is the problem. A jet plane lands on a runway with an initial speed of 300 feet per second, equal to 91.44 meters per second, at time t equals 0, and initial position s equals 0. The acceleration versus time relationship is given in three pieces. From 0 to 10 seconds, acceleration equals 0. From 10 to 20 seconds, acceleration equals -2 times the quantity t minus 10 in meters per second squared, ramping linearly from 0 down to -20 meters per second squared. For times greater than 20 seconds, acceleration is constant at -3 meters per second squared. Determine the time t prime at which the plane comes to a stop and construct the velocity versus time and position versus time graphs. Now let us work through the solution step by step. First, we read the acceleration versus time graph. From 0 to 10 seconds, the acceleration is 0. From 10 to 20 seconds, it ramps linearly from 0 down to -20 meters per second squared, giving a slope of -2 meters per second cubed. After 20 seconds, the acceleration is constant at -3 meters per second squared until the plane stops at time t prime. We also convert the initial speed of 300 feet per second to 91.44 meters per second. To build the velocity graph, we integrate acceleration. During the first segment from 0 to 10 seconds, acceleration is 0, so velocity stays constant at 91.44 meters per second. At t equals 10 seconds, velocity is still 91.44 meters per second. In the second segment, from 10 to 20 seconds, acceleration is -2 times the quantity t minus 10. Integrating gives velocity equal to 91.44 minus the quantity t minus 10 squared. At t equals 20 seconds, velocity equals 91.44 minus 100, which is -8.56 meters per second. Because velocity crosses 0 before t equals 20 seconds, we set the expression equal to 0. Taking the square root gives t sub 1 minus 10 equals 9.563 seconds, so t sub 1 equals 19.56 seconds. Because the velocity is already negative at t equals 20 seconds, the plane must have stopped before reaching 20 seconds. The stopping time was already found in segment 2, as t prime equals 19.56 seconds, approximately 19.6 seconds. Segment 3 is never reached. The velocity graph is flat at 91.44 from 0 to 10 seconds, then curves downward along a parabola until it reaches 0 at 19.56 seconds. Now we integrate velocity to get position, starting from s equals 0 at t equals 0. In the first segment, the velocity is constant at 91.44 meters per second, so position increases linearly as 91.44 times t. At t equals 10 seconds, the plane has traveled 914.4 meters. In the second segment, we integrate the parabolic velocity. The position formula is 914.4 plus 91.44 times the quantity t minus 10 minus the cube of t minus 10 divided by 3, substituting t prime equal to 19.56 seconds with delta equal to 9.56 seconds gives 904.4 plus 874.2 minus 291.2, which equals approximately 1,497 meters. The complete position time graph is a straight line from 0 to 10 seconds, reflecting constant velocity, then becomes a cubic curve with a progressively decreasing slope as the plane decelerates, finally leveling off when the plane stops. The plane stops at t prime equals approximately 19.6 seconds, having traveled a total distance of approximately 1,497 meters from its initial landing position. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.